Hello, welcome to this PPE roadmap film. My name is Ray, and I am the narrator. I am going to lead you through the PPE roadmap. So, let's get started. To get us going, I'm going to put a black dot in this white screen. As you can see, when I move this dot, it becomes a black line. That line represents a timeline. But you also can call it the red thread of this film. It connects and will reveal the PPE roadmap. So, when the line is moving from left to right, we are going forward in time. And when it is going from right to left, we are going back in time. This must be obvious. Unwanted events or accidents happen every day. Disasters, air crashes, terrorist attacks, explosions, and the like all cause the public opinion to be stirred and force governments to respond, take action, and develop rules and legislation. To avoid injuries, the first-line rescue workers who respond to these events are protected by special garments, as well as many other aids. In other words, in a world where disasters can never be excluded, legislation is implemented to protect workers from harm. These garments and other aids are subject to norms and standards. We can conclude that the sheer fact that our society is extremely complex and human activity involves risk-taking, that there are already important drivers for technology development in the domain of personal protection equipment. In this roadmap, we identified a number of drivers in the following domains. 1. Industry. 2. Technology. 3. Economy. 4. Politics and society. We start with some industrial drivers. The business world is changing rapidly, and we have access to the technology that makes it possible to operate our business according to new business models. Outsourcing to low-wage countries and open innovation are clear examples of changing business models. Since technology influences all aspects of human life, it is not only a driver for business innovation, it is also a driver that can stand on its own. In the past, research and technology was seen as an isolated phenomenon. The end user could take it or leave it. This has changed completely. Most development activities are now based on the end user's needs, and development projects often include the voice of the customer. Closely related are the economic drivers. One of the most influential drivers has become international due to all the attention to global warming. Carbon dioxide levels are threatening our society. Cradle-to-cradle solutions and a lowering energy consumption will change our economy. No society or economic system can exist without certain amounts of risk-taking. However, public concern and low tolerance towards the consequences of risk have created the awareness of liability. This has huge consequences for the economic system, especially for PPE. Liabilities are huge, and avoiding these has become an important factor for innovation in this domain. Political and social drivers. Because of the higher level of education and stronger public opinion, many previous unknown risks can now be identified. The awareness of risks is therefore increasing, causing political and social countermeasures. This has a severe impact on PPE. Because of this, higher levels of protection for PPE are demanded and enforced. This is inevitable since it is closely related to the economic factor of liability that we discussed earlier. The 4 drivers identified create the need and the opportunities for future personal protective equipment. These drivers, together with a system approach, will lead to a future of increased levels of safety for protective equipments, their applications, and their future standards. System approach means that the end user in his working environment is placed centrally, and that all aspects resulting from the 4 main drivers are taken into account in the development and the design of a future PPE system. The technology driver is a cluster of many science areas. Within the different science areas, there are developments that lead to modern nanotechnology, biotechnology, macromolecular technology, microsystems and electronics, and advanced production technology, which can be seen as the 5 major enabling technologies for new systems and materials. The first enabling technology, nanotechnology, is a result of modern, high-tech instrumentation with which it is possible to manipulate systems on a nanoscale. Nanotechnology makes it possible to produce nanofibers, nanocomposites, nanoparticles, and to re-engineer surfaces at a nanoscale. With nanofibers that are mainly produced by electrospinning, it is possible to produce ultra-fine webs with a large surface area. They can give excellent protection against chemical and biochemical hazards. Nanocomposites enable us also to produce composite fibers that have improved mechanical and thermal properties, and that can form a better protection against mechanical and temperature hazards. With this technology, it is possible to produce sophisticated sensors, reactive surfaces, and analytical systems on a nanoscale. With nano surface engineering, it is possible to create dynamic, responsive surfaces, to change the surface morphology, and to give surfaces new physical-chemical properties. This can lead to the development of protective clothing with a protection against chemical, biochemical, and electrical hazards. The second enabling technology, modern biotechnology, is a result of recent developments in biochemistry, genetics, molecular biology, cell biology, information technology, and chemical engineering. Developments within the biotechnology that are important for future PPE are biopolymers, enzymes, and biomimics. With biopolymers, it is possible to produce fibers in a sustainable way. They are also applied to make hydrogels that have special response properties, and biopolymers can be applied to modify surfaces of classic fibers like cotton and polyester. This kind of system can be used to create protection against chemical, biochemical, and mechanical hazards. With enzymes, surfaces of various fibers can be modified to obtain special surface properties. They can also be applied to the crafting procedures, the inextricable bindings of specific components to the surface of fibers. Enzymes play a role in the development of fabrics that provide protection against chemical, biochemical, and electrical hazards. With biomimics, it is possible to find benign and sustainable ways to meet our needs for new materials. Examples are camouflage systems, like chameleons have, and light-emitting systems like fireflies have. With biomimics, it is possible to make PPE systems that give protection against thermal and invisibility hazards.